Why can't you tickle yourself? Your brain predicts your moves and cancels the surprise. You can make someone burst into uncontrollable laughter with just a few fingers. Yet no matter how hard you try, you can never do the same to yourself, and that strange failure hides a powerful secret about how your brain works. What if the reason you can't tickle yourself isn't about your hands at all, but about your brain quietly predicting the future and canceling the surprise before you ever feel it? Tickling is one of the most familiar yet mysterious sensations humans experience. A sudden touch on the ribs, the feet, or under the arms can cause laughter, squirming, and a complete loss of control. It happens instantly and often without warning. But there is something strange about tickling that almost everyone has noticed. No matter how hard you try, you cannot tickle yourself. You can touch your own skin, rub your sides, or drag your fingers across your feet. But the sensation never triggers the same reaction. The reason for this lies deep inside the brain, in how it predicts the future. At its core, tickling depends on surprise. When someone else tickles you, your brain does not know exactly when or where the touch will happen. That uncertainty creates a strong reaction. But when you try to tickle yourself, your brain already knows what you are about to do. It predicts the movement, the timing, and the feeling before it happens. Because of this, the sensation is weakened or canceled entirely. The human brain is not just a passive receiver of information. It is constantly predicting what will happen next. Every time you move your body, your brain sends signals to your muscles to create that movement. At the same time, it sends a second signal, often called a copy, to other parts of the brain. This copy tells the brain what sensations to expect from the movement you are about to make. This process happens incredibly fast and without your awareness. When you reach out and touch your arm, your brain already knows that your fingers are about to make contact. It knows how hard the touch will be, where it will happen, and when it will occur. Because the sensation matches the prediction, your brain reduces its response to it. The touch feels normal, dull, or barely noticeable. There is no surprise. When someone else touches you, however, your brain has no advance warning. It cannot predict the exact timing or location of the touch. Because the sensation is unexpected, the brain treats it as important. The signal is stronger, sharper, and sometimes overwhelming. This is why tickling works only when another person is involved. A small part of the brain called the cerebellum plays a key role in this process. The cerebellum is often described as the brain's coordination center. It helps control balance, movement, and timing. But scientists have discovered that it also helps predict the sensory results of your actions. When you move your hand, the cerebellum helps calculate what you should feel next. If the sensation matches the prediction, the cerebellum helps cancel it out. Researchers have proven this through brain imaging studies. When people are tickled by someone else, areas of the brain that process touch become highly active. But when people try to tickle themselves, those same areas show much less activity. The brain is essentially turning down the volume on the sensation. To better understand this, scientists created experiments using machines. In one study, participants controlled a robotic device that touched their skin. When the machine moved at the same time as the participant's hand, the sensation felt weak and not ticklish. But when researchers added a small delay, just a fraction of a second, the sensation suddenly felt stronger and more ticklish. That tiny delay was enough to break the brain's prediction. Once the timing no longer matched expectations, the brain treated the touch as unexpected. This shows just how precise the brain's prediction system is. Even a slight mismatch between what the brain expects and what actually happens can change how a sensation feels. Tickling is not about the touch itself. It is about whether the brain sees the touch as predictable or surprising. This prediction system exists for an important reason. Without it, the world would be overwhelming. Every movement you make would constantly demand your attention. You would feel the pressure of your clothes, every step you take, every blink of your eyes, and every breath you draw. By reducing the importance of sensations you create yourself, the brain allows you to focus on what truly matters: unexpected changes in your environment. The same system works in other senses as well. When you speak, your brain predicts the sound of your own voice. That is why your voice sounds strange or unfamiliar when you hear it in a recording. The sound is unexpected, so it feels different. In vision, when your eyes move quickly, your brain predicts the change in scenery so the world does not appear blurry. These predictions help create a smooth and stable experience of reality. Tickling itself comes in two different forms. The first is called nismesis. This is a light, gentle touch, like a feather brushing against your skin, or the feeling of an insect crawling on you. Nismesis does not usually cause laughter. It may cause irritation or a reflex to brush something away. This type of sensation can sometimes be self-induced because it does not rely heavily on surprise. The second type is gargalesis, which is the classic tickling most people think of. This is the intense, laughter-inducing sensation that targets specific areas like the ribs, neck, feet, and underarms. Gargalesis almost always requires another person. It depends on unpredictability, timing, and social interaction. This is the type of tickling that completely fails when you try to do it yourself. Scientists believe gargalesis may have an evolutionary purpose. Some think it developed as a form of social bonding, especially between parents and children. Tickling often happens during play, helping strengthen emotional connections. Others believe it serves as a protective reflex. Ticklish areas are often vulnerable parts of the body. The automatic laughter and movement caused by tickling may help protect these areas from harm. Tickling also appears to depend on emotional context. People are more ticklish when they feel safe and relaxed. If a person is anxious, stressed, or threatened, tickling often stops working altogether. This suggests that tickling is not just a physical reaction, but also a social and emotional one. The brain must believe the situation is playful, not dangerous. Despite decades of research, tickling remains one of the least understood sensations in neuroscience. Scientists still debate why tickling causes laughter instead of fear or pain. Laughter itself is complex, involving emotional, social, and physical components. Tickling sits at the intersection of all three. What is clear is that tickling reveals something important about how the brain works. The brain is not simply reacting to the world, it is constantly guessing what will happen next. When those guesses are correct, sensations fade into the background. When they are wrong, the world suddenly feels vivid, intense, and real. So the next time someone tickles you and you burst into laughter, remember that the reaction has little to do with the fingers touching your skin. It is the surprise, the unpredictability, and the brain's failed prediction that creates the experience. And when you try to tickle yourself and nothing happens, it is not because you are doing it wrong. It is because your brain already knows the ending of the story and has decided there is nothing new to feel. If you enjoyed this deep dive into how your brain tricks you, subscribe for more science videos that explain the hidden rules of the mind. And tell us in the comments, what is the weirdest thing your brain has ever done to you?